Assalamu alaikum. So we were given assignment by the Professor Salim Alamgir. This is an assignment of a digital logic design, and it's a pretty simple assignment. In this assignment, we would be displaying our registration number, its 9 complement and its 10 complement, and the 7 segment display, and our inputs would be 4-bit binary numbers. So let's get started. First of all, um, let's get basic out of the way. I have already done that, and that would be my registration number, that is 010. And to convert a 3-digit binary number, it's like we will be making a decimal, considering it a decimal. So for to convert a 3-digit decimal number into its 9 complement, it is just by subtracting it by triple nine, and we will get my ninth complement, and adding it with 1 will give me 10th complement. And let's get to the truth table and see how. So this is the table that I have designed. It's a pretty simple table. Let's look at it. First column is the binary column. Here I will be writing my binary numbers, more specifically my 4-bit binary numbers, because that is requirement in the assignment, and we will be using it up to till 9, not more than that, because our requirement is till 9. 10 to 15 will get don't care, so that would be the condition. And in the display column we will be displaying the number that we need to display. Like my registration number is 0 will be displayed in the one column, in the one row, and 010 will be written accordingly. Then it's 9 complement, then it's 10 complement will be written there. And then there is a 7 segment column, and they would be used according to the number that I write. For instance, let's do this. um, 0000, and in the assignment it was written that 0001 would be the should be written according to my first registration number, that is 0. So for 0 to work, I forgot to mention that we will be using common cathode. So in common cathode, 1 will be the high and 0 will be the low. So if we want to write the 0, our G should be low and all of them should be high. So we would do what? A should be high, B should be high, C should be high, D should be high, E should be high, F should be high, but G would be low. So this would be the 7 segment for our 0 number. And then, and like accordingly, for 1, for 0 it would be similar, and like what, 9 8 9 9 90, and it would be same for all of them. We would write it accordingly to the requirement that is needed. Okay, so I have write my truth table into the PC, and see, it's exactly as I have done that in the page. And but I have done one more thing, that would be writing its main term, because we need KMap of each of the segment, and we would be using them to get the circuit. So I have done also that. For A, its midterm are these values, and these would be the for B, C, D, and for up to F. So we would be using this one site that I have found, and it's a very useful site, and it's called Mat for Math. And um, you have to just write your K map here, and it will automatically give you the Boolean expression. First, we will do the don't care conditions, that would be 10, 11, 12, 13, 14, 15. Okay, so that now that don't care are out of the way, let's see what our midterms are. For A, it is 1, 3, 4, 5, 6, 7, 8, 9. So we won't be using 0 and 2. 1, 3, 4, 5, 6, 7, 8, 9. D, B, and A. So this would be my K map for it, and this would be the Boolean expression D, B, and A. So what I will do is go into this site, similar site made by them, made Math for Math, and I will write A plus B plus D, and I would convert it, and boom, it has given me my expression. So I have already done that for all of my other segments. This is for the A, and this is for the B, and this is for the C, and this is for the D, and similarly this is for the E, and this for the F and this is for the G. So I have already done that without any wasting time. Let's get to the next step, which I have already done, that is the Proteus circuit. It was also simple. It's running quite well, just as I've done in the table. That is, let's look at it. What I have done is, I forgot to tell that I will explain it. Like each of the circuit that I've got from the expression, I have implemented in this here, and I have like labeled them. Like this is for A, this is for B, and both some of them had same circuit, so I didn't redraw them. I just used them again. Like B and C had same expression. A, E, and I, if I'm not wrong, A, E, and F had the same expression, so there was no need for to make another one. And G and D had different ones, so only four circuits were made, and we can see that A, D, and F, they had same circuit, so we didn't need to make another one. So yeah, now look at it. What is with my circle? Yeah, let's see. For triple zero, oh sorry, for 0 0 0 0, it should give me nil, and it is giving me nil. And for 0 0 0 1, it should give me 0. And for 0 0 1, it is, I'm sorry, yep, it is giving me 0. For my next expression is 1, so it should give me 1. Yep, I'm getting 1. And let's take another one, that should be 1, yes. And the next one should be 9, sorry, 9, yes. Next one should be 8, yes. So it is working quite well, no issue till now. 9 and 0, as you can see, working perfectly fine. So this was the task, this was the assignment that I have completed, and I hope you appreciate it.